Come to next question. So if we consider the inclined plane and we consider the motion of an object, so it is, the question is what? A block slides down an inclined surface of inclination 30 degree with horizontal. Starting from rest, it covers 8 meters in first 2 seconds. Find the coefficient of kinetic friction between the two. Okay, so how to solve it? So first I will derive a general expression and then I will apply in this particular case. So suppose I have an object here, okay, and this inclination is theta, and so what will be its acceleration that we need to find. So what are the forces? So first is mg, second is normal, and since this object will try to slide down, the friction will be like this, up the incline. Okay, so these are the three forces, and this we can take as x, this we can take as y. Okay, so we will write equations along x and y. So equation along y, if we write, so along y we know that how to split the different vectors. So this is mg. Along y, the component of mg will be what? Mg cos theta, and upper side is normal. So normal minus mg cos theta is 0. Why? Because in y direction object is not moving. So n will be mg cos theta. Okay. Second is equation along x. So if we write equation along x direction, we have mg sin theta part. Mg sin theta along x, and in opposite direction we have a friction. So minus friction equal to ma. So total force, the downward force and the upward force, that is friction, equal to ma. And so how much will be friction now? The friction is, if object is sliding, then friction is mu times normal. So let us put that value. Suppose we write mu times normal and ma. Normal is mg cos theta, so mg sin theta minus mu mg cos theta equal to ma. So if you solve it further, the a is going to be g sin theta minus mu cos theta. Okay, so this will be the acceleration of the object on the incline, and we know that if the surface was smooth, here it is mu. If the surface is smooth, the mu will become 0. So we are having acceleration g sin theta only. So that was for a smooth incline, and if we have a rough incline, then we will write g sin theta minus mu cos theta. Okay, and one more thing to notice here: if the mu cos theta is greater, then the object, the friction force becomes larger in magnitude. The maximum friction force becomes larger. In that case, object will not slide. So this acceleration is there only if sin theta is less than mu cos theta. This is applied only when sin theta is less than mu cos theta. And if you have just reverse, if sin theta is greater than, okay, sorry, I've written just opposite, so I will correct it. If sin theta is greater, only then the downward force will be more and the object will accelerate. But if we have just reverse, if we have suppose this case, then surface is sufficiently rough. The surface is sufficiently rough and object does not slide. Object does not slide in this case. In this case, object does not slide, but in this case, object will slide only. So what will be acceleration for this particular case? For this particular case, the acceleration will be g sin 30 degree minus, how much is mu? Okay, so we have provided starting from rest, it covers 8 meter distance in first 2 seconds. Find the coefficient of kinetic friction. So we have to find the coefficient of kinetic friction. So how to do this? So we will write 10, this is half minus mu root 3 by 2. equal to A. Okay, so we can write like this. Now if we write starting from base covers 8 meter in first 2 seconds, so we can write S equal to half AT square, because starting from west we can write this expression. S, the distance is 8 meter, A by 2 into time is 2 seconds. So how much A we are getting? We are getting 4 meter per second square we are getting. So acceleration is 4 meter per second square. So if you put this 4 here in this expression, we are going to get 4 equal to 10 1 by 2 minus mu root 3 by 2. And if we solve it further, we will have 0.4 into 2 equal to 1 minus mu root 3. So 0.8 equal to 1 minus mu root 3, or mu root 3 equal to 1 minus 0.8, that is 0.2, or mu is 0.2 by root 3. So this is the value of mu for the surface. Okay, for the given condition, this will be the value of friction. So in this way we can find. Any doubt? We have written this acceleration A equal to, we have written the acceleration A equal to G sin theta minus mu cos theta. Okay, so we can take the another condition. If sin theta is less than mu cos theta, if sin theta is less than mu cos theta, what will happen in this case? In this case, the friction coefficient, the maximum friction value is more, and in this case we will not have this maximum value acting, because the object will not start sliding. And if an object does not start sliding, the friction can be anything less than the maximum value. So what we will write is, we have to write like this. From here we will directly write mg sin theta minus friction equal to ma. The friction will not reach its maximum value, and the acceleration will be 0, because object will not slide. Object does not slide. Object does not slide, and the A will be 0. And in this case, the friction will be equal to only mg sin theta. Okay, so if an object is stationary on the incline, it is not sliding, then the friction is not mu mg cos theta. Then the friction is not mu mg cos theta, but it is only mg sin theta, because mg sin theta is the component of gravity along the incline, and only that needs to be stopped by the friction. Why we are getting this? Because this is the applied force along incline. And this we have discussed, that static friction is equal to the applied force if the object does not move. If object is stationary, then we have to write this. So this will be the value of friction force if object is stationary.